Hey everyone, it's that math magician. On this video, we're going to see another example of trigonometry and we're going to see a tangent example. And for this problem, what we have is a word problem that we're going to need to read, figure out what we want to find out, and then use what we know about tangent to help us. So this question says that Salvador has a hot dog stand 58 meters from the base of the Space Needle in Seattle. He prefers to work in the shade and knows that he can calculate when his hot dog stand will be in the shade if he knows the height of the Space Needle. The Space Needle is a building in Seattle. To measure its height, Salvador stands at the hot dog stand, gets out his clinometer, and measures the angle to the top of the Space Needle to be 80 degrees. Salvador's eyes are 1.5 meters above the ground. Assuming the ground is level between the hot dog stand and the Space Needle, how tall is the Space Needle? Draw and label the diagram to help you solve the problem. The question we're trying to answer is how tall is the Space Needle? Well, you know what I'm going to do? I'm going to go ahead and just draw a terrible picture of the Space Needle. This is not at all what the Space Needle looks like, but I'm going to call that our Space Needle. And we know that Salvador has a hot dog stand that is 58 meters from the base of the Space Needle. So I'm going to go ahead and draw Salvador over here standing, and we're going to label this distance here as 58 meters away. And we know that when he's looking at the top of the Space Needle, he's measuring an angle to be 80 degrees. So now I'm going to get look at the top of that Space Needle, and I'm going to draw a dotted line to show that Salvador is looking at the top at an angle of 80 degrees. Now he's looking at it from his eyes, right? So what I need to do is I need to now draw a line going straight across from his eyes to the Space Needle to show that this angle here that he's finding is 80 degrees. And we're interested in figuring out how tall the Space Needle is. We can label the Space Needle as X. So look what's forming here. And again, I'm a terrible artist, so this drawing is not drawn well. But what we have is a right triangle that's hiding in our diagram, right? This angle here is going to be a right angle. We know that this angle from his eyes up to the top of the tower is 80 degrees. And we know this distance between him and the Space Needle is 58 meters. So we can definitely figure out what X equals because this is a tangent problem. So let's set this up. Tangent of 80 degrees is going to equal the opposite side. Let's go ahead and draw in our opposite side. Our opposite side there is going to be X over 58. We'll put the left side over 1. We'll cross multiply. We can solve for X. So let's see, X times 1 is going to give me X, and X is going to equal 58 times tangent of 80 degrees. Now is the time where you get your calculator and you punch that in. What is 58 times tangent of 80 degrees? Let's go ahead and see right here. Clear out my calculator. So for this calculator here, I need to go ahead and switch it into scientific mode so that I can use trig. And I'm going to type in 80, and I'm going to hit the tangent button. And that's the tangent of 80 degrees. And then I'm going to times that by 58. And we end up with our value of X being 328. Remember, I always want three numbers after the decimal. So 328.934. 328.934 meters. But now we have to put our brains on for a second and think about this. We solved for X. X is this length of the right triangle. So did we really solve for the height of the Space Needle? I don't think we did, right? I don't think we actually found the height because we are missing that distance right there. That bottom distance. Really, that distance, if I go to the right, that's the distance of Salvador's height to the ground, from his eyes to the ground. And what's great about this is that the problem told us how high up his eyes were above the ground. Right here it says Salvador's eyes are 1.5 meters above the ground. So I know that this distance here is 1.5 meters. I know that this distance over here is also 1.5 meters. So if I want the total distance of the Space Needle, I need to take X, I need to take Salvador's height, and we need to add those together. We add those together, and we're gonna end up getting our actual height of the Space Needle. So let me get my calculator back out. Let's go ahead and add. Whoops, I went too far back with that. We'll type in 328.934. We'll add his height of 1.5, and we know that the height of the Space Needle is going to be 330 feet, 0.434 meters. That right there is the total height of the Space Needle, and we found it again by using tangent. Tangent helps us. We had to draw the diagram first. Let me be clear, if a question says draw and label a diagram, you need to do it, because reading this question, there's no way to know that this is a tangent problem unless you draw the diagram. But once you have it drawn, you see, we want to use tangent, we want to find X, the height of the Space Needle, but you have to remember that if we're finding this height of X, we also need to add in the height from the person's eyes to the ground, okay? But if you can do that, add those two numbers up, you'll get the correct answer every single time. It's that Math Magician, and I'll see you on the next video.